Question 1, we're given all the information about the Venn diagram and we've just got to fill in the numbers and then work out the probability of the number being A intersect B. So let's have a look at these sets here, and we can say to ourselves that 8 is common to A and B, so it would be in here. It doesn't, oh, it also lies in C. Sorry, let's have a look. So it would be a really nice one to get going with. So there we go, there's 8. Now let's have a look at the 2 here. The 2 just seems to be in A, as does the 10 and the 14. Now the 6 is just in B. The 20, however, is in B and C. The 18 is just in C. And the 22 is in C. So we've got to make sure we've got everything. So the universal set is going to be all the even numbers between 1 and 25. So we've already got 2. Have we got 4? No. 6 we have. 8 we have. 10. I can't see a 12 there. I can see a 14. So there's no 16. There is an 18. There is a 20. There is a 22, but I can't see a 24. So that would be the Venn diagram sorted out. All we've got to do now is say a random number is chosen from the universal set. Find the probability that the number is a member of A intersect B. Well, the only number where they overlap, there's only going to be one in there as far as I can see, and that's the 8. So that's one number only out of how many numbers altogether? Well, let's have a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the probability to be 1/12. Question 2. I've written some answers on here already. LOBF means line of best fit. So Sean has information about the height in centimetres and weight in kilograms of each of 10 rugby players. He's asked to draw a scatter graph and find a line of best fit. There's his answer. Sean has plotted the points accurately. Write down 2 things that are wrong with his answer. Well, I've said the line of best fit does not suit all the points, or you're allowed to say should be amongst the crosses. You know, it should really be more down here, shouldn't it? I've noticed also, didn't notice it straight away, but after a bit of looking I saw that 150 wasn't even mentioned. So you could say the x-axis is inaccurate, or you could say the height scale, because this is the height, it's not linear because it goes from 140 to 160, which is 20, and then a step of 10. So they're just a few of the things you can say that's wrong with his scatter diagram. Okay, or scatter graph as it's called here. So that's question 2 sorted out. Question 3, BEG is a triangle which is given, and all we've got to work out is the angle x, and we're given some parallel lines here. Now, one clever way of doing this is, and I'm going to probably do this freehand just to give you an idea that it's not too bad. I'm just going to draw a parallel line through here, parallel to these two. So I probably could do the arrow going the other way would probably help. So I can give that as a parallel line as well, but it has to go through this point here. That's really important, because what you've now got is an alternate angle to 25, and now you've got another one here. So there's 2. So you can say that this one here is 35 because of alternating angles or alternate angles, and this one's 25. Looks like 250 there, doesn't it? Let's put it smaller. So what we can say is x is equal to 60 degrees, and we'll give our reasons, because alternate angles. So we can say this point here was G, wasn't it? So I'll write that in. So we can say angle GEF equals angle EG, and we'll just call this H, I think, here. Doesn't really matter. Equals 25 degrees, and we can say angle CBG equals BGH equals 35 degrees, and just write that in again, alternate angles. These questions are rather annoying because you just have to write the information to get the marks. So that's what I would do in that particular question. Use a ruler, but just make sure that you put this arrow on here to indicate that it's parallel to this one and this one. That's really important. Question 4. Northern Bank has two types of account and they both pay compound interest. So Ali invest £2,000 in the cash savings account, and it's 2.5% per annum. So the multiplier is going to be 1.025 because that automatically adds on the 2.5%. And that's done over 3 years. So instead of writing 1.025 times itself, we can just write cubed. And we can do that on the calculator right now. So we've got 2,000 times 1.025 to the power 3, and that's going to be £2,153.78 because you want it to the nearest penny. So £2,153.78. And Ben, well, he has 3.5% per annum, but a smaller amount to start with. So that's 1,600, and that's over 3 years as well. So that's 1.035 cubed. So 1,600 times 1.035 to the power 3. That gives 1,773 pounds 95. The nearest penny. So you can see that who gets the most interest, well, just take it away from the principal amount. So you're going to get £135.78 compared with £173.95. Okay, so who will get the most? Well, Ben will get the most quite clearly from that. The next part of the question says, in the third year, the rate of interest for the shares account is the shares account. Now, be careful, it's not for both, it's just for this shares account. So for this one, so just for Ben. It says that in the third year, the interest rate is changed to 4% per annum. Does this affect who will get the most interest by the end of the 3 years? Well, it doesn't affect who will get the most. I think it's going to be clearly Ben. So I'm going to write that down now. So clearly Ben will still have the most interest because even at 3.5% he had more. So 4% will only increase his interest. So can you see what I mean? If it was 1.035 for the final year, he still had more. So if you made the final year 4%, because he had more at 3.5% overall, by changing one of them to more than 3.5%, i.e. 4%, it's not going to change who has most. He's still going to clearly have more. Okay, so that's what I would write for that 1 mark there. Question 5. The diagram shows a floor in the shape of a trapezium, and John is going to paint the floor, gives you information about the costs and how much 1 litre covers an area of 2 metre squares. He has £160 to spend on paint, and we've got to see, has he got enough money to buy all the paint that he needs? So we've got to show all our working, obviously. So first of all, I think we find the area of the trapezium. So the area of the trapezium is the perpendicular height halved, and we do the sum of the sides that are opposite. There's plenty of explanations as to why this is the case. I'm not going to go into a great amount of detail proving the formula right now. We're just going to use it. So we've got 7 for the height, and then we've got 10 and 16. So we've got 7 over 2, there's 26, and so that's 7 times 13, and we can use our calculator for that if you want. That's 91. So 91 metre squares. We know that 1 litre, it covers 2 metre squares, so we're going to see how many 2's go into 91. So we're going to do that. So 91 divided by 2, that's going to be 45.5 litres needed. Now, each 5 litre tin costs £16.99. So how many are we going to need? Well, we're going to do 45.5 divided by 5. And that's going to be 9.1 5 litre tins. Well, if you think about it realistically, to be honest, realistically, you could probably, dilute the paint a little bit and make it work. But in this particular question, you've got to be really strict with yourself and say, I know you'd want to get away with it in real life, but in terms of the question, if you bought 9 tins, 9 5 litre tins, you would not have enough. So you can't just buy 9.1 tins, you've got to buy 10. So we want 10 lots of 5 litre tins. So that's going to be 10 lots of £16.99, which is £169.90. So he has £160 to spend. Has he got enough money? And we can say no. He is £9.90 short. Question 6. A is the point with coordinates 5, 9, and B, D, 15. And it says the gradient of the line AB is 3. So we can say that's 3, but how do we find the gradient? Well, it's the change in y over the change in x. So there's 2 different ways we can do this. We can either say 15 minus 9 divided by d minus 5, or we could say 9 minus 15 divided by 5 minus d. Doesn't really matter which way. So I'll just do this one. So we can say that 15 minus 9 over d minus 5 equals 3. So we multiply. So first of all, we can do the numerator, which is 6. Multiply both sides by d minus 5. And then that gives us 3d minus 15. Add 15 to both sides. And then divide both sides by 3. So we get d is equal to 7. Maybe you want to try this one and see if you get the same answer. You should. Question 7. We want to write this number 0.000008623 in standard form. So standard form has to be a number between 1 and 10, so that's the number 8.623. But 10, 100, 1,000, 10,000, 100,000, so it has to be divided by 10 once, twice, 3 times, 4 times, 5 times. So it would be 8.623 times 10 to the minus 5, which is the same as 8.623 divided by 10 5 times. So part B, we've got to work out this expression. So I'm going to do the top part first on my calculator. So I've got 3.2 times 10 to the power 3 plus 5.1 times 10 to the power negative 2. That gives me 3,200.051. And I'm going to do the bottom part now. And I'm just going to write that in because to get the final answer, I'm just going to have to be a little bit careful on my calculator. I'm going to put a bracket around this. And then on my calculator, I'm going to do that number divided by, and then I'm going to put a bracket around this as well. Now, I don't think the first set of brackets are really necessary, but I think it just gets you in that frame of mind to be careful, because if you forgot the brackets here, these ones here, then what the calculator would do is it would take this number, it would divide it by 4.3, and then it would times the final answer by 10 to the minus 4, which is not what you want. You want this number divided by all of this number. So my advice is just put the bracket here in here to section that part off. You then press divide, and then you open another bracket and another one, and I can guarantee you won't mess up. So you put the first number in, which I've already got in my calculator anyway, and then I'm going to press divide, but then the brackets underneath are really, really crucial. So that's 4.3 times 10 to the power negative 4. And what that gives me is 7441979.07. Now be careful, we want it in standard form, correct to 3 significant figures. So standard form is going to be this many powers of 10, so it's 1, 2, 3, 4, 5, 6 powers of 10. And we want it to 3 significant figures, 1, 2, 3, so it'll be 7.44 times 10 to the power 6. Question 8. Triangle P is reflected in the line y equals minus x to give triangle Q. Well, the line y equals minus x goes through these points. So if I do that first, let's have a look. So that's our line y equals minus x. And a nice way of looking at that is you can see that it's going to be the same distance away from the mirror at right angles. And it's the same with this one. 1, 2, 3. So again, 1, 2, 3. Now, because you've got the longer one here, which I'm just going to do freehand, not very well, but that'll do. You know that this is going to be this one here, and then you can join this last one up, like so. And so you can call that Q. Triangle Q is reflected in the line x equals negative 1. So what's that going to look like? Well, there's x equals negative 1. And what we're going to do is be careful. So 2 just away from there, and then 2 the distance from there. And then likewise this one here. I might change the colour to something else. Let's have a look. There we go. So, trying to do this freehand. I should use a ruler really. And that's going to be R. So what we've got to do now is describe fully the single transformation that maps triangle R to triangle P. Well, I don't know if you knew this, but if you have two reflection lines that aren't parallel and they cross, then that's going to be the centre of rotation. So our centre of rotation is going to be negative 1, 1. Now all we've got to do is work out how to map R to P. Well, one nice way is to look at this line here. Can you see it ends up like this? So it's going to have to be rotated 90 degrees to get from a vertical to a horizontal. So 90 degrees is what we're going to need. So we can just write anti-clockwise degrees. So I think as long as you've got the keywords rotation, the centre of rotation being negative 1, 1, and then anti-clockwise 90. You can say clockwise 270, that would be acceptable, but generally angles always turn in anti-clockwise fashion from 0. Question 9. Martin truncates the number n to one digit. The result is 7. Write down the error interval for n. Well, for me, truncating doesn't have an effect of rounding, it just cuts away the decimal points. So, for example, the number could have been 7.0000, and to truncate it to one digit would just be to cut away the decimal point and the numbers after it. So it could have been 7. Could it have been 8? Well, no. It could have been 7.99999 and so on, which rounded would make 8. But if it just had, a million nines after the decimal point and you truncated it to one digit, then you would get 7, but the answer could have been right up to but not including 8, which you could write like this. But we've already said the answer could have been 7. So my interval would be as given. So just be careful not to mix up truncation with rounding. Question 10. Robert makes 50 litres of green paint by mixing litres of yellow and litres of blue. And he does that in the ratio of 2 to 3. Now, it's quite handy if we see 50 litres here to change this to 20 and 30, isn't it? Because then we can have 20 litres to 30 litres. That's the first thing that I think I would do. Now, yellow paint is sold in 5 litre tins. Well, that's good because 20 divided by 5, that's going to be 4 of those. So you want 4 tins of yellow. And blue paint is sold in 10 litre tins, so we want 30 over 10, so that's 3 tins of blue. Well, 4 tins of yellow, that's going to be 4 times 26 in pounds, and 3 tins of blue, that's going to be 3 times 48, so 4 times 26 on the calculator. That's £104, and 3 times 48, that's 144. So the total cost that is spent on the paint is going to be 104 and 144, which is £248. Robert sells all the green paint he makes in 10-litre tins, and each of them is £66.96. So don't forget he had 50 litres, that's 5 of those. So he sells it for 5 times 66.96. So on the calculator, that's 5 times 66.96, which is £334.80. So his total profit as a percentage. So we want to look at the difference between what it cost, which was 248, what he sells it for. So we'll do the two numbers taken away from each other. Doesn't matter about the sign, just the positive will do. So that's £86.80. And we're going to compare that to what it cost. Okay, so we're going to have 86.8 divided by, or compared to, £248, and to make it a percentage we'll times by 100, because this will just be a decimal, won't it? So if we do 86.8 divided by 248, that's 0.35, and of course if we times that by 100, that's going to be 35%. Question 11. In a restaurant there are 9 starter dishes, 15 mains and 8 desserts. Janet's going to choose one of the following combinations for her meal, and that is a starter dish and a main dish first. So for each of the starter dishes there'll be 15 choices for each main. So altogether there'll be 9 times 15 ways for the starter dish and a main dish. Then it says or, so we're going to add here, just like we would in a probability diagram, we'd add the end of the particular branches. So we're going to have main, well there's 15, and for each of those we need to choose a dessert, and there's 8 ways for each of the mains that we choose. So that's 15 times 8. And a starter dish, a main and a dessert. So we're basically going to have the same situation here, 9 times 15 times 8. So we're going to do this one first on the calculator, or you can do that in your head. So 9 times 15, that's going to be 135. 15 times 8, I know that in my head, so that's 120. And then we've got 9 times 15 times 8, so I'm just going to have that one, that's already in my calculator, and times it by 8, and that's 1080. Then all I'm going to do is add these together, and we're going to get 1080 plus 120 plus 135, and that is 1335 altogether, which is what we wanted to show. Question 12. We've got an expression here, and we have to put it in a certain form. And it wants it in the form ax plus b divided by cx plus d. So I'm going to put some brackets in here. First of all, I can see a difference of 2 squares. So that's 2x all squared minus 3 all squared. I'm going to take out a 3 from here. Put brackets around this. And then I'm going to have my 2x here. And then I'm going to take an x from here. So first thing I can see is that this x and this x cancel out. I'm then going to write this as the difference of 2 squares in the form, if you have a squared minus b squared, that would be a plus b times a minus b always. So this can be given as 2x plus 3 multiplied by 2x minus 3 multiplied by this 2, don't forget, all divided by 3, lots of 2x plus 3, x minus 3. So I can see here this cancels also, and I just have to multiply this back in. So you'd have 4x minus 6 over 3x minus 9. And that would be the form that you wanted it in, ax plus b over cx plus d. So the next part, we've got 3 over x plus 1 plus 1 over x minus 2 minus 4 over x. Well, we would like a common denominator of x plus 1, x minus 2. So for this one, we're going to have to times top and bottom by what was missing. So we want to times by x minus 2 and x. So in other words, x minus 2, we'll do it in that order. For this one, if we wanted to have the common denominator of x plus 1, x minus 2, we're missing the x plus 1 and the x this time. So we've just got to times that 1. Well, I don't need to write the 1, do I? So I just need x times x plus 1 there. And for the 4, likewise, I would just need x minus 2 and x plus 1. So I'll just have 4 lots of x plus 1, x minus 2. Now, for those of you that don't quite get that, if you have a fraction, I'll just write it like 3 over x plus 2 over x minus 1 for simplicity. If you want a common denominator of x minus 1, then it's like you timesing this top and bottom by x minus 1 and this top and bottom by x, because then you get x minus 1 in both cases, and then you've got the 3x minus 1 here plus your 2x here. So I've done just the same with this one. Okay, so I can now sort out the top numbers. So I'm going to have 3x squared minus 6x plus x squared plus x, and then I think I'm going to bracket that off and have x squared minus 2x plus x minus 2 all over that denominator. So that's going to give me, well, let me just write this top part out with the bracket expanded. Be careful, 2 minuses there under multiplication make a plus, and again here. Forgive me for writing all this over these lines here. I'll make some room now. So if we put that to one side here, we can now cancel out. So we've got a 3x squared minus 4x squared, which is minus x squared plus x squared, 0x squared. So they're vanished. We can just double check. 1 and 3 is 4, minus 4 is 0. So they've gone. We've now got 4x, 5x, minus 6x, so that's minus x. And we've got nothing else apart from this 8 to sort out. And then underneath. So that seems to be the answer. I think I would prefer to write the 8 first and then the minus x last. And I would write that as my answer. Nothing else cancels, so this question is now finished. Question 13. The diagram shows a circle and an equilateral triangle. One side of the equilateral triangle is the diameter of the circle, and it says the circle has a circumference of 44 centimetres. So the circumference of a circle is pi times its diameter. And it's saying the circumference of the circle is 44. So that means the diameter, which is also each side of the equilateral triangle, of course, will be divide both sides by pi. So that's 44 over pi. So I'm going to put that in first. Now, work out the area of the triangle. Give your answer correct to 3 significant figures. Well, I think the way I would do that is, I'm sure you think the same, I'm going to find the perpendicular height, and then I'm just going to do base times the perpendicular height, and then halve my answer, and then give it to 3 significant figures. So I think what I'll do is, throughout this question, I'll write down things in terms of pi, if that's okay. Of course, you can go straight to your calculator, but I think it would help also to help you with the non-calculator paper kind of techniques as well, because sometimes they do ask to keep things in terms of pi. So bear with me if I use pi throughout. Of course, you don't have to, okay? So I know using Pythagoras in a right-angle triangle, this is going to be 22 over pi here. I'm going to have 22 over pi all squared plus h squared is equal to 44 over pi all squared. So from that, h squared is going to be 44 over pi all squared minus 22 over pi all squared. That's difference of 2 squares, so it's going to be 44 pi plus 22 pi times 44 over pi minus 22 over pi, and that's going to give 66 over pi times 22 over pi, and that's h squared. We want h, so from that we can say h is equal to root 66 times root 22 over, but that's pi squared, and that's going to be square rooted, so that's just going to be pi here. Okay, I could do those in third form, but I won't in this particular case. So there's h. So the area is going to be the base of the equilateral triangle, which I've got as 44 over pi, times the height, which I've got here, I've just worked out, and then I'm going to halve it. So I'm now just going to put in the numerator, so that's 44 times root 66 times root 22, and that's going to be 1676.625182. Then I'm going to divide that by, open a bracket, don't forget, so I'm going to make sure that it divides by all of this. Pi times 2, close brackets. And just so you know, I'm just going to keep that as 2 pi squared because I didn't show what that was. And my answer is 84.93882397. Wants it to 3 significant figures. So 84.9 centimetre squares, and that's to 3 SF. Okay, so what I would do now for this question is maybe try it with decimalising this straight off, but just be really careful that when you decimalize these things here, that you write down all the display in your calculator. Don't try and truncate or round until the very end of the question. Question 14. On the grid, sketch the curve with equation y equals 2 to the power x, and give the coordinates of any points of intersection with the axes. Well, I'm going to go up in ones on this axis. 1, 2, 3. and so -1, -2, -3. And then I'm going to go up in 2s, 4, 6, 8, 10 here. And then going to go down in 2s here. So let's have a look at what we've got first. So when x is 0, we're going to have y equals 2 to the power 0, or anything to the power 0, that's going to be 1. So, and we're going to mark that off here. When x is 1, we're going to have y equals 2 to the power 1, which is just 2. So when x is 2, we're going to have y is 2 squared, which is 4. And you've probably got the next one. That's 2 to the power 3, which is going to be 8. And so on. Now let's do some negatives. So if x equals -1, y is going to be 2 to the -1. And don't forget that's the same as the reciprocal, so that's 1/2. And then we're going to have 2 to the -2, so that's going to be 1/4. Now it's very hard to do the scale properly, because what you'll miss on the left hand side here, you've gained here, but then if you made the y-axis go up in any more, so if you went 2 was here, then you'd have 4, but you wouldn't be able to get the 8 on here. I know you'd get more of these involved, but you'd get less of these, so you're going to have to make a trade-off somehow. So what I'm going to do is just complete that for you now. And I think what you can see is, there's my best effort. What we shouldn't have is any crossing of the x-axis here, because it will never get to 0, because 2 to the power negative a massive number is going to be 1 over 2 to the power of a massive number, which is going to be close to 0, but not ever going to get there. So the x-axis is an asymptote. And it did say we've got to show the coordinates of any intersection points, and so we're going to have this one as being 0, x is 0, y is 1, and we're not going to need any other information there, so that's that question finished. Question 15. The equation of a circle is x squared plus y squared is 42.25. Find the radius of the circle. Well, the equation of a circle around the origin with radius r is x squared plus y squared is r squared. So all you have to do is say, well, r squared is 42.25. You just want to find the square root of that. So on your calculator, 42.25 to the power 0.5, or use your root sign, whichever, and you get a nice answer here of 6.5. You don't need to write -6.5, because when you've got a radius of a circle, it goes in all different orientations from positive to negative. So it's just the actual modulus, or the actual length is what you need, which is 6.5. The direction's not important. Question 16. There are only red counters and blue counters in a bag. It says, Joe takes at random a counter from the bag, and the probability that the counter is red is 0.65. So that tells us straight away that the probability that the counter is blue is going to be 0.35. Joe puts the counter back into the bag. Mary takes at random a counter from the bag. She puts the counter back into the bag. What is the probability that Joe and Mary take counters of different colours? Well, we can either have red first, then blue, or blue, then red. So red first would be 0.65. Don't forget the counter's put back, and then we can have the blue, and that would be 0.35. The counter's then put back, So we could have had then the blue first being chosen and then 0.65. So if we multiply these out, we're going to get 0.65 times 0.35, which is 0.2275 in each case because they're just switched around. And so if we add those together, because this is an OR relationship here, so we times by 2, and we're going to get 0.455. That's part A. Part B says there are 78 red counters in the bag. How many blue counters are there in the bag? Well, the probability of being red is 0.65. So if 0.65 was the probability of being red and there were 78 red counters, then we've got to find how many blue counters there are. So we've somehow got to get to 0.35. So I'm going to divide both sides here by 0.65. And that's going to give me 1, and here 78 divided by 0.65. I'll do my calculator. That's going to be 120 counters. Now that makes sense because the probability being 1 is all of the counters. And that means I can find out straight away how many blue there are, because I can just say, well, if the probability was 1, that's all of the counters. And if I had 78 red, I can do 120 take away 78. And that would leave me with 42. But if that doesn't help you, don't worry. We can just get to 0.35 by timesing the 1 by 0.35 and doing the same to this side. So as long as we do both the same to both sides, we can get the proportion correct. And 120 times 0.35, well, lo and behold, that is 42, which is what we wanted anyway. So there's a few ways of doing that, but that's just a couple of ways for you. I'm sure you may have your own way of doing it. Question 17. P and Q are two numbers such that P is greater than Q. And it says when you subtract 5 from P and subtract 5 from Q, the answers are in the ratio 5:1. It says when you add 20 to P and add 20 to Q, the answers are in the ratio 5:2. So first of all, this would mean that Q minus 5 was worth 1 unit, but then P minus 5 was 5 times that 1 unit. So that would mean that 5 lots of Q minus 5 would be P minus 5. Let's look at this now. Let's try and get one of them to be 1. So it doesn't matter which. Let's say this one. So we divide both sides by 2. So we'd get 5/2 or 2.5 to 1. So if this is 1 unit, then P plus 20 is 5/2 or 2.5 times more than that. And that would give us P plus 20. So looks like we're going to have some simultaneous equations here. So what I'm going to do is I'm going to multiply this one out. And then I'm going to get the P's and Q's on one side and the numbers on the other. So I'm going to add 25 to this. and that's going to give me my first equation. I'm going to multiply both sides of this one by 2. Multiply out the brackets. And then I'm going to get the P's and Q's on one side. And then I've got my equation B here. So I'm going to now look at these simultaneously. So 5q minus p equals 20. And 5q minus 2p equals negative 60. I can see the coefficients here are the same, so I'm just going to times one of these equations by negative 1. I'm going to do this one. And I'm going to add these equations together left and right, so I'm going to get the q's are going to vanish. I'm going to be left with p because I had negative p and 2p, so that's just p, and that is 80. So p is 80, and I'm going to sub in a. So that's 5q minus 80 equals 20. So 5q is 100, adding 80 to both sides, and then I'm going to divide both sides by 5. So q is 20. Now p is greater than q. Yes, we've got that. So the ratio of p to q is 80 to 20, but in simplest form, well, we're just going to divide both sides by 20, and that will give us 4 to 1, and that would be the final answer. Question 18. The straight line L1 passes through the points with coordinates 4, 6 and 12, 2. And so we can find out some information from that. We know y equals mx plus c. Some of you use y minus y1 is mx minus x1. It depends which one you want to use. So we can find the gradient first. So the gradient of L1 would be the change in y. So I'm going to do 6 minus 2. This one, change in the y. You can do 2 minus 6, it's up to you. Divided by 4 minus 12. And that's going to give us 4 over negative 8, which is negative a half. And so I'm going to just use y equals mx plus c first. I'll do it both ways if you want, because some of you like different ways. So I'm going to choose a simple coordinate, so 4, 6. So I'm going to let y equal 4. So y equals 6 rather, so I'm going to have 6. M I already know, it's negative a half. X I know from this one, because I've chosen 4, 6. I could have chosen 12, 2, it doesn't matter which one. Plus c, so it gives me 6 equals a half of 4 is 2, so that's negative 2 plus c. So c will be 8. And so I've got the gradient now, I've got the intercept, so y is going to be minus a half x plus 8. Some of you would rather write it as that. That's absolutely fine. Doing it the other way, you can choose your coordinate. So why don't we just choose this one, and see if it makes any difference. So we're going to have y minus 2 is the gradient, x minus 12. So times everything by 2 to get rid of this denominator here. So we're going to have 2y minus 4 equals minus 1 lots of x minus 12. So that's 2y minus 4 equals negative x plus 12. So that means 2y is going to be negative x plus 16. And divide both sides by 2 here to get y on its own. Would be minus x over 2 plus 8. So the same way there. So see which way you like best, and then you can go your own way with it. So we know that L2 passes through the origin and has gradient -3. So we know straight away that the intercept's going to be 0 and the gradient's -3, so it's quite easy. We can just write that straight down. Now we want to know where they intersect. So from here, we had y was equal to minus x over 2 plus 8. Here we have y equals minus 3x. So yes, we just put them equal to each other. Times both sides by 2 here. I would add x to both sides. And then I'm going to divide both sides by -5. So x is going to be -16/5. And I'm just going to put this into one of the equations. I think this is the nicer one to use. So if I call this A, I'm going to sub in A. So y is going to be -3, lots of, be careful, 2 negatives under multiplication are going to be positive. So we're going to have 48/5. And you can use your calculator if you're not sure of how to do -3 times -16. So our answer is going to be x is -16/5 and y is going to be 48/5. And that's that question sorted out now. Question 19. We've got an inequality. And all we've got to do is find the region that m can lie in. So what we're going to do is we're going to times everything through by 4. 4 is a positive number, so it's not going to have any change of the inequality sign going on. So we're going to have 22 times 4 is 88. M squared plus 7 is left here, and then 4 lots of 32. On your calculator, if you want to use that, that's fine. It's 128. I'm now going to take 7 off each part because, again, that's going to be fair to the inequality and not change its sign. So that's going to leave me with 81 is less than m squared is less than 121. So what I'm going to do now is I'm going to look at each case separately, because those that rush in on here and just square root and think it's between 9 and 11, that's only going to be part of it. Okay, so what I would personally do is I would look at this first and say 81 is less than m squared, which means that 0 is less than m squared minus 81. And if 0 is less than m squared minus 81, that means m squared minus 81 is greater than 0. Okay, so just think about that. If 0 is less than m squared minus 81, then m squared minus 81 is greater than 0. That's the difference of two squares, and that's quite important. So I would say m plus 9 times m minus 9 is greater than 0. I'm going to put -9 and 9 here quite clearly. Then I'm going to say to myself, where is this expression? And this is a quadratic expression. Look, it's just here in this form as well. Where is this expression greater than 0? Now we know if I was to plot this quadratic, can you see that its coefficient here is +1? So it's going to have this kind of shape. So I would just do that shape just to kind of remind myself what's going on. And I would say to myself, I want it where this quadratic is greater than 0. So I want this region here, and I want this region here. So from here, I'm going to have m can be greater than 9, or m can be less than -9. So that's the first part done. Now I'm going to look at this part. So that's m squared is less than 121. So that's m squared minus 121 is less than 0. So that's m plus 11, m minus 11, less than 0. So that gives me negative 11 and 11 as cutting points. They are the important parts that I want to look at. And I want to be where this quadratic is going to be less than 0, and this quadratic is going to have the same kind of shape. And where is it less than 0? Well, in here. So that's where m is between 11 and minus 11. So all I have to do now is put this information on one number line. So I put 11 here, 9, and then I wanted minus 9, and I wanted minus 11. I don't have to do it to scale as long as it's in some reasonable kind of scale. So if I look at this carefully, I can see that one of the first ones I wanted was m can be, let's move this, it's playing up a little bit. So what I want to do first is look at this one, and that's between 11 and minus 11. So I can draw that. And this one, I want m to be greater than 9, or m to be less than minus 9. Now, I hope you can see very clearly now that the region that overlaps is between negative 11 and negative 9, and between 9 and 11. So my final answer would be for this one, I would have m between minus 9 and minus 11, and I would also have m between 11 and 9, and that would be my answer. Question 20. We're given a frustum of a cone, we're given some formulae here, and we're told that the diagram shows that the frustum is made by removing a cone with height 3.2 centimeters from a solid cone with height 6.4 and a base diameter 7.2. And it says the frustum is joined to a solid hemisphere, so it's taken here and it's joined to a solid hemisphere of diameter 7.2 centimeters to form the solid S shown below. It says the density of the frustum is 2.4 grams per centimeter cubed, and the density of the hemisphere is 4.8 grams per centimeter cubed. So we want to calculate the average density of solid S. Well, I think the first thing to look at is, because this is 3.2 and this is 3.2, then if this is 7.2 here, then this is going to be 3.6 centimeters. And if you think about it, because this 3.2 here is half of what the height would have been, which is 6.4, then in proportion it's going to be half of what the base diameter would have been. So in terms of proportion, you can do it in terms of a ratio if you want. So we've got the radius here, or should I say the diameter, as 3.6. That's the first step. So what I can do is I can find the volume of the frustum, and we know that's going to be the volume of what the cone would have been. So that's going to be 1/3 of pi times 3.6 squared times the height, which would have been 6.4. Take away this part here, which is missing from it, don't forget. So that would be 1/3 of pi times the radius, which is, I'm careful now, that's 1.8 squared, times the height, which is 3.2, not 6.4 this time. So that's the volume of the frustum, and on the calculator we can put that all in. I'm not going to leave it in terms of pi, so I'm going to put this in. And that's going to be 76.00140948. So that's everything on my calculator display. Now, what I'm going to look at next is that the mass of the frustum. So don't forget, density is how much mass you have per volume. So I know the density because it tells me here. So the mass of the frustum is going to be density times the volume. So it's going to be 2.4 times what I had in my calculator. So 76.00140948 times 2.4, which is 182.4033827, and that's going to be grams. I've left out the dimensions here. It doesn't really matter for now, as long as we've got our final answer in grams per centimetre cube. That's all we should be worried about right now. So I'm going to keep that there. And what I'm going to look at next is I'm going to look at the volume of the hemisphere. So that's going to be, if it's a hemisphere, we need to halve what the sphere would have been. So it's going to be 2/3 of pi times the radius, which is 3.6 cubed. On the calculator, that's going to give me 0.716979. So I can work out its mass in the same way as I did for the frustum, and I can just do that quickly. So that's going to be 400. I'm not going to put equals because it's rounded. So on the calculators, that's 469.0372699. So now I've got all the information. So to calculate the average density of the solid S, I'm going to do the sum of the masses, so the total mass, over the total volume. So the total masses are going to be these two added together, which I can just work out. So that's going to be 651.4406,526. The total volumes is going to be these two. So that's going to be 173.7175074. And then if I do those one divided by the other, that's going to give me 3.749 recurring, which I'm going to write as 3.75, and I'm going to do that to 2 decimal places, and that's in grams per centimetre cube, which is already given. So, quite tough. It'll be quite easy to make a mistake on that question, but hopefully you've followed it all the way through, and a good use of the calculator is vital in this type of question. Question 21. We're given what looks like a really complicated question here, and we're going to try and make this as easy as possible. So we're given all the points, and we're told where the centre of one of the circles is, O, and the two circles intersect at the points A and R. Okay, that's fine. And CPA, CRB, and AOB are straight lines. Okay. we've got to prove that angle CAB is the same as angle ABC. Well, the first thing I'm going to do is I'm going to label one of the angles. So let's have a look. I think I'm going to make a radius happen here, and I'm also going to look at this circle, the larger one. So if you look at this circle here, can you see we have a cyclic quadrilateral? Now I'm going to call this angle here x. So this angle here should be 180 minus x. So I'm going to write angle CRO is 180 minus x, and that's because opposite angles in a cyclic quad add up to 180 degrees, and if this one was x, then this is going to be 180 minus x, because 180 minus x and x is 180. So that's step one. Step two is, from that, I think you can follow that this angle here would have to be x. So angle ORB is equal to x, because angles on a straight line add up to 180 degrees also. Now let's have a look at step three. What I would say is that OR and OB are radii. So OR is equal to OB, and that's because they're radii from the same circle, which makes triangle ORB isosceles. Hence, angle RBO equals x also. So I think we're just about there, because looking at the diagram clearly, we've found this angle to be x. I'm going to write over the b so you can see it. So we know that angle CAB is x, because we started with that, and we've shown that angle ABC rather is also x. I know here we called it angle RBO, but can you see that angle RBO is the same as angle ABC? Because R lies on CB, doesn't it? Because it tells us this information here. It tells you they're straight lines. So we can say from this angle CAB equals angle ABC. Okay, so I did try this question before with a colleague, and we went round and round and round doing it so many horrible ways. And then suddenly we both saw this way, which was just really quick. So just using opposite angles of a cyclic quadrilateral seemed to get things unfolding really quickly.